This is question number 73 in chapter 8. It says a 5 kilogram chunk of ice is sliding at a 12 meters per second speed on the floor of an ice-covered valley when it collides with and sticks to another 5 kilogram chunk of ice that is initially at rest. Since the valley is icy, there is no friction. After the collision, how high above the valley floor will the combined chunks go? So here's our image. This one. We have one that's going to slide together, and they're going to change their kinetic energy into gravitational potential energy. We won't need the angle for anything because there's no friction. Anyway, just some thoughts. I was confused on it first. So we can just take our conservation of momentum equations and solve for the first part of this. Mass times V naught equals mass plus mass times V. That's just like your final velocity. And we have our values for this. So it's 5 times V is 12. Yeah, 12 meters per second equals 5 plus 5 V. And V would then come out to be, I think that's 6 meters per second. So V is 6 meters per second. I'm tired. That's not, oh man, long day. V equals 6 meters per second. Now we can take this and so we have the velocity of our kinetic energy that goes into our kinetic energy, and we can set it equal to gravitational potential energy. So you have your 1/2 mv squared, but we're going to change it into 2m because there's two of the masses, equals, again, 2m times gh. We have all the values we need for this, but we are going to solve for h first because that's the question, is how high above is it going? How high? That's what we want. You divide over, those get crossed out, then you just have 1 b squared over 2 g h. We'll change that over here. So we just have v squared over 2 times gravity. So we plug in our 6 squared over 2 times 9.1. That will give us our height, which is 1.8 meters. So wasn't this fun? Enjoyed myself. We have 1.8 meters above the valley floor.